Hello everyone. So today what I want to do is I'm going to go over the actual practice final and I'm picking C for each single one. So 1C, 2C, and then we'll be doing A's in class together. So then you get to practice with all of the B's. Since this isn't actually an assignment that you'll be turning in, I'm going to do the same exact problems that you're going to be working on. Just because I know that there's 27 total and that's a little excessive. So starting off with 1C, remember that with this, we want to start off with combining like terms. So I'm going to go through and identify what those like terms are. I noticed that this here is a number, and then a number. But I also have things with variables. So this is a variable, and this has a variable. That means that I'm going to be combining the numbers with themselves and the variables with themselves. So the first thing I want to notice here is that I have two numbers on the same side of the equal sign, and then I have a number on the other side. When you are combining two numbers on the same side of the equal sign, you do not do inverse operations. You just combine them as what it says. So here you have 3 plus 9, so you would get plus 12. The only time you do inverse operations is when you do from one side of the equal sign to the other, which is what we're going to do in a second. But here I'm going to bring down my 4x, and then my 5x minus 13. So again, I notice I have my numbers, and I have my variables. I want to go ahead and combine my variables next. You could keep going with the numbers if that's what you choose. Now that I'm going from one side of the equal sign to the other, I'm going to start doing inverse operations. So this is a positive 4. You saw here was a positive, so it came down a positive. I'm going to do the opposite, which is subtract. That canceled that out, and I was left with a 12 is equal to 5x minus 4x is just x minus 13. I'm going to go ahead and bring down my equal sign. Now I'm going to combine my numbers. So here I have a negative 13. I want to do the opposite, which is add. And I get 25 is equal to x as my final answer. Okay, our next problem is talking about transformations. So just to bring back what that is, we did a little bit of it, I think it was chapter 1, where we talked about that each letter represented a different transformation. So we have a plus or minus. This tells you whether it opens up or down. The A tells you whether it has a vertical shrink or stretch. The H will be your horizontal shift, but remember that this one is always the opposite. So here, if it's a positive 2, then we would go to the left, and if it was a negative 2, we would go to the right. And here are a couple examples. Here we had x minus 3. So we do the opposite, which is to the right, and we go 3. Whereas in this one, it was x plus 1, so we went to the left one because we take the opposite. And then the vertical shift doesn't do any opposites. It's just what it is. So here's plus 2, we go up 2. Here we had negative 4, so we went down 4. So let's look at this problem here. The first thing I want to do is identify all of my transformations. So I am going to take this here because that tells me one thing. This number here will tell me another thing. This number here, will tell me another thing. And then lastly, I'll do this color. This here will tell me something else. So let's start off with that negative 2. If we look back at our notes, the negative number in the front will tell us whether our parabola will open up or down. So since this is a negative, that tells me that it's going to open down, meaning it'll look something like this if I did a rough sketch. Now the 4. So the 4 will tell us whether we have a vertical shrink or a stretch. If the number itself, just the A, not the sign in front of it, but just the A number, if it is less than 1, then we have a shrink. If it's greater than 1, we have a stretch. So here I am comparing this 4. Remember, it's not a negative 4. It is just a 4. Since 4 is greater than 1, we will have a stretch. Now looking at our 2, remember I said it's the opposite. So since this is a minus 2, this tells me I'm going to move 2 units. Instead of in the negative direction, I'm going to do the opposite, which is to the right. And then lastly, the 3, I'm going to move down because it's negative 3 units. And that's it. Okay, for our next one, we want to solve this system of equation by using either substitution or elimination. Now, that was a really big topic that we talked about back in chapter 1. We have 3 different methods of solving. We have graphing, we have substitution, and we have elimination. We want to use substitution when we have something that is y is equal to or x is equal to, when our equations are set up in that way. So if I take a peek at the problem that we have in front of us, it's not set up like that. We have both variables on one side of the equal sign. So we don't have any that look like this. Something that would look like that is like this one that we did, where it's x is equal to something, and then the x is by itself. The next method that we talked about was elimination. Now we want to do elimination when we either have the same or when we have opposites. So that would be something like we did here. We saw that we had a negative 9x and a positive 9x. Yeah, we don't have opposites with the y's, but we only need one of the variables to have opposites or the same. So when I look at this, we notice that I actually do have the same right here. I have a 3y and a 3y. Remember that they have to be the same number and the same variable. You can't have like a 3y and a 3x. Those wouldn't be opposites of one another. So when we have the same, it tells us we're going to subtract our equations together. So what I'm going to do is I'm actually going to rewrite this, because when I subtract this second equation, that's actually saying that I'm going to distribute that negative into every single term in that second equation. So just to make things cleaner, I'm going to copy my first one because nothing changes with that one. Minus, so a negative and a positive become a negative and a positive become a negative and a positive become a negative. So essentially what I did was I subtracted so that I can then get these opposites here. Once I have the opposites, I can add straight down. I know that these two, when I add, will cancel each other out, and I would be left with 7 minus x would give me 6x is equal to negative and a negative will give me negative. 23 and 7 gives me negative 30. I can go now and solve for my x, which is x is equal to negative 30 divided by 6 is negative 5. But I'm not done yet. That is just my x value. I'm now going to use my x value to substitute it into either equation to solve for my y. So it doesn't really matter which one you plug it in. I'm just going to do the smaller one, the bottom one, because I notice the numbers are smaller. I see that 23 and I don't really want to deal with it. So I am going to do x, so I'm plugging it into this one here, plus 3y is equal to 7. Now remember, I am plugging it in for my x because x is equal to negative 5. So there's my negative 5 there. I can bring down my equal sign. So I get negative 5 plus 3y is equal to 7. So I'm going to go ahead and just move that over now. 3y is equal to 7 plus 5, which is 12, divided by 3. Y is equal to 12 divided by 3 is 4. So now that I have my y and I have my x, I can write those as my answer, which would be negative 5, 4. That means that these two equations intersect at this point, which is my solution. Now, if you're comfortable with elimination, you can keep it that way. Personally, I like using substitution. So I'm going to set that up for you real quick and show you how you can manipulate any equation to use either method that you want. So this is set up with the same, but what if you don't have the same, right? What if this was like an 8y instead? I find that substitution is easy, a little bit easier than elimination. We know that substitution, we want the y or the x to be by themselves. And right away, I select that x. I know that the x is kind of by itself. It doesn't have a coefficient. So this has a 7, that has a 3, that has a 3. The x will be easy to manipulate to get by itself because all I have to do is get rid of this 3y. If I do that, then the x is by itself. Then I can use substitution. So again, I'm going to rewrite this. I'm not changing the top, so I'm going to write that again. Now the bottom one, I want this x to be by itself. That means I need to get rid of that 3y. So to get rid of it, I'm simply going to subtract it to cancel it out. But what I do on one side, I must also do to the other. So here, since that canceled, I'm left with my x. And I like to line up my equal signs. It just makes it easier for me. That canceled out, so I am left with negative 3y plus 7. I can't combine these two, so I just write them as an equation. From here, I identify what letter I am going to substitute. So I have my x, which is going to go into here. What I'm substituting into that is this equation right here. So when I rewrite that, I get 7, whatever I'm plugging in for x, plus 3y is equal to negative 23. What I'm plugging into that is this part right here, which is negative 3y plus 7. I'm just substituting it in. Now I'm going to distribute. 7 times that is negative 21y plus 49 plus 3y is equal to negative 23. So this becomes just like a problem that we did in number 1. Negative 21 plus 3 would give me minus 18y, and then negative 23. Subtract my 49 on both sides. Just going to bring it up here. So negative 18y is equal to, what would that be, 72? Now I'm going to divide by 18 on both sides. And I would get y is equal to 4. So if you notice, this y and this y would be the same thing. You could plug this back in. So I'm going to plug it into this bottom one. So x plus 3y is equal to 7. Plug in my 4. X plus 12 is equal to 7. And x is equal to negative 5. So again, combining those two things, I get negative 5, 4 as my coordinate point. With the first way that I did it, let me zoom out. The first way that I did it was elimination. So I'm just going to write that off to the side. With elimination, you want either opposites or the same. The second way that I did it is substitution. If you're not given clearly a method which to use, you can manipulate it. You see that I ended up manipulating both of these so that I can get what I want. You want, for substitution, for it to look like this. For elimination, you want either the same or the opposite. All right, let's move on. Okay, now we're going to be talking about finding the vertex. This was more of chapter 2, I'm sorry. When we look at this, it looks a little bit complicated because we have a negative, we have a fraction, we have an 11. Those are really big numbers. But I want to bring you back to our general form of vertex form. So that is f of x is plus or minus a x minus h squared plus k. Now this one is pretty helpful because if I were to pull out my h and k from my equation, that actually gives me my vertex. So that's all I have to do here. I have to identify my h and my k. So my h and my k. In place of my h, I have a 5. Now that's a positive 5 because the negative is part of the equation. And I have a positive 11. You can think of this like transformations. If you were to pull just the last two transformations, which we did over here, how left, how right, how up or down, that's all you need to know for your vertex, which is 511. Okay, so this first one for C, when we did that, that was given to us in vertex form because it had the parenthesis in the exponent. And it was written for us as if we were going to do transformations. 5C is given to us in standard form. Now with standard form, it's not as easy as just pulling out the numbers like what we just did. So with this one, we're going to need our axis of symmetry to then pull that out and find our vertex. So if you guys remember, our axis of symmetry is the equation x is equal to negative b over 2a. Looking back at our notes, we have them here. We need to find our axis of symmetry, by doing the negative b over 2a. And once we did that, we substituted that value, that axis of symmetry, and back into our equation, solved it. Then those 2 points together gave me the vertex. So let's go ahead and find our a, b, and c from our equation. So a is the number in front of x squared, which in this case is negative 2. B is our b value, which is in front of the regular x, negative 12. And then c is 17. In this case, we won't need the c, but it's still good practice to identify it. So I'm going to go ahead and put negative b over 2 times our a. Our b is negative 12 over 2 times our a, which is negative 2. So negative and a negative would give me a positive 12. 2 times negative 2 would give me a negative 4. Simplified, this is negative 3. That means that my axis of symmetry is x is equal to negative 3. Now remember, if it were asking you for your axis of symmetry, your answer should be this entire equation, not just negative 3. You need to put the x is equal to negative 3 if all it wants to know is your axis of symmetry. In this case, it wants the entire vertex, so we're going to substitute this value back into our equation and solve for the y. So negative 2x squared minus 12x plus 17. In place of those x's, I'm going to put that negative 3. I'm going to change the color because it looks too close for me. So I'm just going to finish it off in this color. Remember that when you're doing this, you want to do the exponent part first. So negative 3 squared is positive 9. Which I'm going to multiply by that negative 2. A negative and a negative would be plus 36. And then plus 17. Negative 2 times 9 is a negative 18 plus 36 plus 17 Negative 18 plus 36 is 18 plus 17. 18 plus 17 is 35. So that means that my f of x is equal to 35 and my x is equal to this. Therefore, combine those 2 points together and I get negative 3, 35 as my vertex. Like I said, this is chapter 3. So if you guys want additional practice problems, this is something that you might want to review. Okay, next up is 6C. With this one, it's asking us to find the roots. When it wants you to find the roots, what it's actually asking you to use is the zero product property. Now remember, the zero product property says that you want to know where this equals 0. In order for something to equal 0, that means that your factors, one or both, must equal 0. So I'm going to set each one of these things equal to 0. X minus 7 is 0. X plus 11 is equal to 0. And then I solve. So add 7, x is equal to 7. So I can do this as a coordinate point of 7, 0. And then my other one, negative 11, which canceled that one out. And I get x is equal to negative 11. And as a coordinate point becomes that. Therefore, my roots become this. Or you may also leave them like this here. Okay, for this one, it's asking you to simplify. What looks weird about this one, especially considering the last few things that we did in chapter 5, is this negative sign in here. So because that is what's confusing me most here, I am going to rewrite my radical as the square root of 50 times the square root of negative 1. 50 times negative 1 gives me this negative 50. So I'm going to focus with something that I can do and then just deal with the negative, the funky looking thing at the end. So I'm going to break up 50 and I'm going to say, this is 10 times 5, which then is 2 times 5. So 50 is 2 times 5 times 5. And I'm just going to bring down that radical negative 1. Now, since this is the square root of something, that means I want groups of 2 of the same number to come out. So I have this 5. So 5 comes out. The 2 stays inside. It doesn't have anyone to pair up with to come out. So that stays like that. If this was a problem that looked just like this, I would be done. My answer would be this here. Plus or minus 5 radical 2. But because I still have this this negative 1 here, I just gave it away. The definition of the square root of negative 1 is I. Anytime you see a negative instead of a radical, you know you're going to have an I. So all I'm going to do is squeeze that into here, and that becomes my answer. You want all of the things outside of a radical, you want them out in the front. Everything that is in a radical, just leave it out at the end. It's kind of like if you were to write like 5x. You wouldn't write x5. You would write numbers first, the variable at the end. The radical is kind of like the same thing. So just leave the radical at the end. Alright, x minus 1 is equal to negative 3x squared. I know that by looking at this, the first thing you want to think of is like SATMERP, right? You want to solve and get the x's by itself. But because I notice that I have 2 x's on opposite sides that I can't even combine, I don't want to think about that. I want to solve this a different way. So let's put everything on the same side. I'm going to add, no, you can move this to the other side, but I don't like a negative when it comes to x squared. It just looks ugly to me. So I'm going to add the 3x on this side, which cancels it out. And I'm going to move it over here. So I get 3x squared plus x minus 1 is equal to 0. Now when you're doing this, you want to solve, you now see you have a trinomial, right? So you might want to do factoring. And if something is not factorable, then you want to use the quadratic formula. I'm going to look at this and I'm going to try to factor it just because factoring seems like it's a lot shorter. So 3, 1, and -1. I'm going to use my x here, so that is -3, that is a 1. And then I'm going to need my area model, so I'm just going to fill that in since I'm already here. 3x squared and then -1. So whatever two numbers I pick will end up going here too. So I want two numbers that when I multiply them gives me -3, but when I add them gives me 1. And I can't think of any, so I'm just going to list out all of the numbers that multiply to give me 3, and that's 3 and 1. There's no way I could do either -3 and +1 or +3, -1. There's no way that I can combine those to give me that 1. So this problem becomes unfactorable, which kind of stinks now because I did all of this work. So I'm going to keep my same information here, but I'm going to have to use the quadratic formula. So the quadratic, if my past decided to work, my quadratic formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Since I have my a, b, and c off to the side, I am just going to plug those things in. -b plus or minus the square root of b squared minus 4 times a times c, and that's all under the square root, all over 2 times a. All right, so -b is 1, plus or minus b squared, so 1 squared. 4a is 3. C is -1 all over 2a, which is 3. All I did was plug in the numbers from my equation into my formula. Now I can start simplifying it. So -1 plus or minus the square root of 1. So -4 times 3 is -12 times 1 is a +12 over 2 times 3, which is 6. So -1 plus or minus 1 and 12 is 13 over 6. Now I want to take that 13 off to the side and I want to see if I could simplify it, but 13 doesn't simplify it into anything. It's a prime number, so the only numbers you can multiply to get that is 1 and 13. Therefore, this becomes my answer. Just be careful when you're typing or looking for this answer in. If you don't have that symbol, you can just break this down as -1 plus radical 13 over 6 and -1 minus radical 13 over 6. This is the same thing as that. Sometimes the symbol doesn't pop up as one of the options when you're entering this in, but you could do it this way just with a comma or something like that. All right, last but not least, let's look at number 9. All right, 9C comes from our last chapter. So we know that this is going to involve everything that we've just done. I've mentioned that a few times. The first thing I want to look at is I want to get rid of this radical so that I can start moving things around. In order to get rid of the radical, we need to square both sides. So it looks like this. I know that if I were to expand this here, that would be x minus 2 times x minus 2 is equal to just the inside because the radical cancels out, which is 24 minus 3x. Now you could go off to the side, which, I mean, it's the final. I suppose I could do that and show all of my work. So x minus 2, you can't see what I'm doing here, but there it is. I get x squared minus 2x plus 4. I noticed that I could combine these because they are like terms, and I get -4x. So now I'm going to bring this information back. I get x squared minus 4x plus 4 is equal to this 24 minus 3x thing that I had to start off with. Now I want to start combining my like terms. I'm going to zoom in since I don't need that anymore. I'm going to add the 3x and combine it with the negative 4x. Get that canceled. Then I want to take this 24 and combine it with the 4. I get x squared. Negative 4 plus 3 is minus x. And then 4 and negative 24 is minus 20 is equal to, since all of that canceled out, it's going to be 0. So again, I'm going to try to solve this by factoring just because I know it'll save me so much work. So hopefully it's factorable this time. A, B, and C. So 1, negative 1, and negative 20. A times C goes on top, so negative 20. And then at the bottom, I have my B. Use my area model. The first term goes in the first box. The last term goes in the last box. Now I want to look for two numbers that multiply to give me negative 20, but add to give me negative 1. And those will be the numbers that I put in here. So 2 and 10 won't work. 1 and 20 won't work. But 5 and 4 multiply to give me 20, but one of them has to be negative. Since I have a negative 1, that means my bigger number will be negative. Negative 5 plus 4 gives me negative 1. So here I put in negative 5x, and here I would put in 4x. Remember, it doesn't matter which order you put it in. You can swap these around, the green ones, as much as you want. As long as they're in those diagonal boxes, it doesn't matter. So now I want to pull out my GCF. So what do these two have in common? Well, they only have an x in common. That leaves me with an x here. So then what do I multiply by x to get negative 5? Negative 5, and then plus 4. So my factored form is x plus 4, x minus 5 is equal to 0. This becomes another finding the roots problem like we did. So I'm going to set, I should have actually put my line here, but x plus 4 is equal to 0, and x minus 5 is equal to 0. And I'm going to solve for x. So x is equal to negative 4, and x is equal to a positive 5. These are my possible answers, but I won't know for sure until I check my work. So my last step here is to test my solutions. I am going to take that x is equal to negative 4, and I am going to plug it into my original equation, which was x minus 2 is equal to the square root of 24 minus 3x. But then I'm also going to take that second point and do the same thing. So x minus 5, plug it into x minus 2 is equal to 24 minus 3x. And I know you can't see that yet, but I will put it there when we get there. So x minus 2 is equal to 24 minus 3 times x. Substitute my x values, and I get negative 4 minus 2 is negative 6 is equal to 24 plus 12. Bring down my negative 6. That gives me 36. The square root of 36 is 6. So remember that we're only using the positives when we do square roots in this chapter. Therefore, negative 6 does not equal 6. And this would give us an extraneous solution, meaning it's wrong. We don't want to use that one. We're going to now check for the 5 and hope that we have better luck. So x minus 2 is equal to 24 minus 3 times x. Plug in 5 and 5. 5 minus 2 is 3. Okay, so 24 minus 15. 24 minus 15 is 9. The square root of 9 is 3. Since 3 is equal to 3, x is equal to 5 is our only real solution. Now I took up a whole paper showing all of the steps. You could have probably done this a lot shorter. But there that is. You have the rest of this practice final to work on your own. Good luck, and it's been great. Bye.